everyone, and thank you for tuning in. I'm Michelle Sargentson, Director of Integrated Marketing at SingleStore. We've got a fantastic event planned for you today. Everything from new product features and demos to fireside chats with industry thought leaders. So get ready, because we're kicking things off with our CEO, Raj Verma, to share his take on the database industry and the real-time revolution.
My name is Raj Verma, CEO SingleStore, and it's my absolute pleasure to welcome you to Revolution 2022. We're going to actually have a real conversation about real time today. I know there's a lot of noise going around in our market about real time. Every man and his dog has a real time system all of a sudden. So we're going to have, as I said, a real time with Raj this morning and with the rest of my colleagues. I think that should be entertaining. At least we hope it is. We're going to talk about the mission of SingleStore, and we're going to briefly touch upon the purpose that we all, me and my colleagues here at SingleStore, and share that briefly with you. And we also then have some exciting news to share with you, which we will. So the real conversation on real time. Now, just imagine a day in your life. Let's imagine a day in my life. I wake up every morning, most mornings, to having these Amazon fresh packets outside my door. I help my wife bring it in as I call the Uber to go to the office. And as I ask Linda, who runs my life here at SingleStore, to order me some lunch, which she, again, gets delivered most of the time. And I take a Uber back, and on the Uber back, I'm listening to my favorite songs, which is, again, as a service. That is my real-time world. Now imagine that world where the groceries that we wanted this morning arrived tomorrow. The Uber that I ordered to get to the office by 8:30 in the morning got there by 11:30. The lunch came when it was dinner time. The music did not play. You get the point. The real time has to happen now, not 20 minutes later, not 5 minutes later. It is all about sub-second response times. And that's why we wanted to clear the air here with you so that you can differentiate the real-time companies from all the companies who can talk the talk but cannot walk the walk. And to go there, let's just talk about what makes a system or gives the system the capability to be real time. It's not magic. It's actually simple. Real time needs fast. Fast equals real time. Now let's think about it. What makes a technology fast, a database fast? It's not query optimization. All right, 5, 7, 10% maybe. It's really the storage architecture. We were built to be real time. We have a 3-tier storage architecture, memory, disk, and object store, which puts us in a very unique position to provide you millisecond response times, to be able to, at the same point in time, give you the lowest TCO of anyone in our industry. Don't take my word for it. We have a study by an independent third party, GigaOhms, and I'll highly encourage you to go take a look at that. The second thing which allows us to deliver real time to you is what we call unification of 2 real big aspects. The first is the various data models, JSON, text search, streaming data. Now that allows you to do most of your work on one single platform rather than having these swim lane databases stitched on to your database. And the biggest is the unification of transactions and analytics. Now, this has been in the works for over a decade now, so this was a pretty difficult task. A lot of people often ask me, do you really do that? Well, I'll encourage you to try it and let me know, because we actually really do that. And what that allows you to do, and I'm really excited that later last month, or earlier last month, we announced Workspaces, the general availability of Workspaces, that allows you to, on the same screen, be able to take a look at your transactions and on the same workload, do your analytics without having to ETL or copy and paste that workload. When data moves, bad things happen, and it introduces a lot of latency. So we are real-time by design because we are fast owing to our storage architecture and our unified data models and the unification of transactions and analytics. You're going to hear later on in the show today from our head of products, Yatharth Gupta, head of engineering, Shireesh Thota, and also our customers and partners about, first, how we build this, and secondly, how our customers use this. We are at a crossroad in business today where the incumbent vendors, right, which have a stranglehold on the data industry, are right now finding themselves coming up short to meet the requirements of the modern day. It is our mission to ensure that we can educate you, our customers, prospects, and developers at large, that at last there is a better way for you to shape the future for your organization by using technologies like SingleStore, which are fast, they are real-time, they're unified, and importantly, extremely resilient. We are committed to distributed SQL, which will make us among the most resilient technologies or databases in the world. We are committed to ensuring that we always remain real-time in our analytics. And thirdly, we are absolutely committed to giving you, the developers, one of the best experiences that you can get from a database. It is absolutely a privilege to, in some small way, being able to make this world real-time. I was talking about the ride-sharing company. We help them in a little way. When I bank and I log into my bank account, the fraud detection in that bank account, we enable that. Some of the offers that you get when you demonstrate a certain behavior so that your needs and experiences are enhanced, we do that. We help some of the Fortune 100 companies to close their books and report it as a public company on time. Predictive analytics, which allows cell phone towers to stay online for longer, for devices, large computers and servers and equipment to remain on a higher uptime. That is highly, highly fulfilling. But our mission is to continue to push the envelope on data. And that is something that you would see from us in the times to come. Now, as I've always said, and I'll touch upon it briefly, you need to know in the modern era, just having the best technology is not good enough. Absolutely, there is no if, and buts about it. The business of business is for profit. That particular line is no longer applicable in the modern business world. The business of business is to ensure that we can affect the lives of people who come in touch with us. We can improve them, we can better them, we can keep them safer. And I just wanted to briefly touch upon that we are not only committed to delivering the best technology, the best experience in real time, but we are also committed to making the world around us better. What drives us is to ensure that everyone is not only born equal, but is also treated equal. And I do want to touch upon some of the issues that the world is facing today and just put it out there as to what our stance on that is. And I think it's important for you developers to know that this technology is built by people who have a greater purpose than just zeros and ones. We are absolutely committed to our colleagues, to the citizens of Ukraine, in their difficult time, in the various atrocities that they've had to deal with. Our employees are safe, they are looked after, and in turn, doing a great service for their fellow citizens, and I couldn't be more proud of them. We absolutely stood by the Pride Month last month in San Francisco. Actually, I had a lot of fun, and it was just awesome. And lastly, just something which is extremely close to my heart is some of the recent rulings that the Supreme Court had. Deeply, deeply upsetting for me as a father of two daughters. I'm privy to some very unsettling conversations on the dinner table. I feel for all the women in the world who are hearing this, watching this, and just women at large. These are frightening and unsettling times for all of you, and our thoughts are with you on this. And I just want all of you to know that we will leave no stone unturned to ensure that each and every woman in the world gets the right to the right health care of their choice. There are just no ifs, ands, and buts about it. Lastly, I want to share some really exciting news with you. We, as you might have read recently, announced our latest round of funding. It is just a further validation of support on our mission and our purpose at SingleStore. We are delighted to work with Goldman Sachs, who are not only a large customer, but also now an investor. They have made us better as a company by using our product, and I know they'll make us better as an investor by partnering with us. So thank you. We also welcome the other new investors. Deep, deep, deep gratitude to our partners and investors, IBM, HPE, and Dell. It means the world to us to have you as our investors and to partner with you. The use of funds are actually going to be very simple, very aligned with our mission and our purpose. We will absolutely be dedicated to providing you the real-time experience, so the analytics will always remain at the cutting edge. We will absolutely double down. We are doubling down on distributed SQL so that you have world-class or best-in-class resiliency and uptime. And lastly, on the developer experience. And from our purpose perspective, which is enhancing the lives of people who touch us, we promise you that we'll do everything that we can to give you an equal opportunity in this world. Thank you for your time today. I hope you enjoy the sessions from our leaders, from our customers, and our partners. Stay well, stay safe. Thank you.
Thank you for that inspiring keynote, Raj. Let's dive right into the latest product features and what's new in SingleStoreDB with our SVP of Engineering, Shireesh Thota.
Hello, I'm Shireesh Thota. I'm Senior Vice President of Engineering at SingleStore. I'm excited to be here to talk about what's new in SingleStoreDB. I've spent the past 2 decades working on various kinds of databases, and I'm thrilled to be here to help with the vision of building a general-purpose unified database for both speed, scale, reliability without losing performance. Before we get into the details of what's new in SingleStoreDB, I want to present a little bit of a context and the history of all the work that has happened here. First, the context. If you look at the modern data stack, it's kind of broken. The complexity of these transformations in the silos lead the customers to build a lot of siloed enterprise architectures. What ends up happening is that the time to insight is much larger. They want to minimize it from the time a transactional piece of data enters the system to when the business wants to gain some insights. That essentially means that you need one engine that can build both the transactional capabilities as well as analytical. And SingleStore has been at the forefront of that, and the fact of the matter is that we're the leaders in this space. HTAP is not necessarily a new concept. It's been there for quite some time. Real-time analytics is the killer application, and that has been made possible for some of the innovations like cloud architectures, evolutions in our query engines, etc. And SingleStore has definitely taken advantage of it. If you look at the history of SingleStoreDB, we've started out as an in-memory OLTP database. We wanted to provide a really quick low latency access, and we've succeeded at that. Beyond that, we've added columnar formats on disk, foraying into analytics. We've built an amazing architecture known as universal storage, where we could do both the transactions with our row store skip list indexing in memory and columnar formats on disk. We further forayed into tiering the data into an object storage with bottomless architecture. When we did this, we've taken immense care to make sure that we don't impact the operational latency and yet provide an amazing scan performance. The details of this are presented in many of our research papers, including the recent SIGBOT paper. And now we are here where we're focused on building new capabilities for enterprise scale, real-time analytics, and developer experience. Let's dive in. These are the three pillars that I talked about. Number one, enterprise scale. Number two, developer experience. Number three, real-time analytics. I'm going to touch upon some of the core features here. On enterprise scale, we begin talking about Workspaces, which is a core feature which is useful for our customers to build isolated compute workspace environments. These isolated environments can be built on the same database, just attached on demand. This essentially means that one could imagine building applications such as point-in-time sales, segmentation, BA dashboards, all on the same data without having to move the data, without losing any performance, and no additional cost. Along with that, we've introduced an HTTP API to interact with our control plane. Also enhanced our security posture significantly. We've added features such as CMK general availability. We've added things like single sign-on with popular identity providers. We also have now support for JWT token authentication. These all features help our customers to have zero trust policy capabilities in their business. Moving on to the developer experience, we start out talking about the code engine. It's powered by Wasm, WebAssembly. WebAssembly, as we know, is very popular for building highly efficient applications for web. Now, the thing is, Wasm also has amazing characteristics such as portability, safety, and the nature of the code format, which is in binary. It helped it evolve the interfaces to be run on different kinds of runtime environments. We're proud to announce that we are deeply integrating this into the database engine so that programs such as written in languages such as C, C++, Rust, that can be compiled into Wasm modules, can now be run closer to the engine, closer to the data, without having to move the data back and forth. This essentially means that you don't have to pay for the mid-tier unnecessary movement of data, suffer with the latency, etc. And that's a huge step in the right direction in terms of really building a unified interface for doing local analytics. We're also providing support for HTTP RESTful data APIs. And finally, we are enhancing our built-in vector functions, where you can do some advanced algorithms such as image recognition and such within the database itself. Now to the last pillar, real-time analytics. Here we started talking about flexible parallelism. This is a feature which helps the query to take advantage of the entire hardware, effectively running on all cores, a single query running on all cores, which means that the powerful queries, complex queries, can take advantage of it and be a lot more powerful. What used to happen was that we used to provide one thread per partition earlier. Now we divide the partition into logical subpartitions and assign a thread per logical subpartition. This essentially means that we could now exploit all the cores. We've seen some of our customers take a benefit of almost 4x performance because of this feature. We're also excited to announce that our Power BI connector is now certified by Microsoft, so you don't need any third-party extensions. On the dbt adapter, this helps our developers to build workflow environments. You could do transformational pipelines on the data natively present in SingleStore, further boosting the CI/CD pipelines. So this is about all the features that we have. A lot of these details are going to be covered in the next deep dive sessions. I encourage you to go watch it. But before we go, I want to point your attention to one last thing. We recently have had the study done by an independent vendor, GigaOM. They were looking at our TPC performance benchmarks as well as our TCO metrics. And the idea here is, what does it take for an equivalent system to build something that SingleStore provides natively, to do both transaction and analytics in one place? The results were stellar. The study finds out that we were 50% cheaper for an equivalent stack of Snowflake and MySQL. We were 60% cheaper compared to a Redshift Postgres. Now, once again, you need more than one solution here, because you need to have both transaction and analytics in one place. Versus in SingleStore, you don't need to. And that's one of the reasons why it's much cheaper. On the TPC benchmarks, we were found to be 100% faster compared to a Redshift equivalent. I also want to point out that SingleStore is one of the only databases that can do TPCH DS competitively with the cloud data warehouses, as well as TPCC benchmark in a very reasonable scale. Thank you.
Hi, my name is Sverre, and I'm a Senior Director of Engineering on the Launchpad team. One of the best parts of my job is building applications which showcase the unique and interesting capabilities of SingleStore Database. So when I was asked to build a demo for the launch event, I was stoked. I think the conversation went something like this. Hey Carl, can you make a demo for the 7.9 launch event? No problem. How does a universe simulation sound? Just imagine thousands of solar systems full of millions of spaceships. Okay, I get really excited about universe simulations, but luckily Raj said yes, and we were off to the races. So we had an idea. And as I was saying, the idea of thousands of solar systems and millions of spaceships flying around a virtual universe just sounds really compelling. But could you build it using only a database? Could we use one database to do everything needed to power this entire simulation? Well, you'd need a couple of pretty hard features in such a database. The first one is you'd need to be able to handle transactions and analytics at scale. At the very least, to simulate this universe that I have in mind, we'll require over 1 million transactions per second, or more specifically, 1 million update operations per second. And that's just to move the ships around and let them react to their environment. So transactions are going to be extremely important. But while those transactions are happening, we're going to need to run a lot of analytics to be able to render the game UIs and make them look super cool. And speaking of game UIs, well, I don't want to just power one game client. I want to be able to power thousands of game clients, which means that we need all of those analytics to run with high concurrency. So this is just yet another hard problem to stack on top of an already really hard problem. And finally, we would need to be able to extend the database with custom logic. I want my spaceships to have behavior. I want them to have AI, and I want them to be able to react to their environment in a semi-believable way. And for that, I want to write behavior or an AI for these spaceships in a higher level language, so I can leverage open source libraries and just use all the tools that I'm used to as a software engineer. So these are my requirements for building a universe simulation. And before SingleStore 7.9 came out, I didn't have all of these things in one database, but now I do. So I'm introducing the Wasm Space Program. Let's go check it out. This is the universe. The universe is full of solar systems. Each of these yellow symbols on your screen is a solar system. Currently, there's about 32,000 solar systems in the simulation. And within all of these solar systems is about 1 million spaceships. So we have a live universe that is running in real time. We can see that the current turn time is about 755 milliseconds. As long as that's less than once per second, we are in real time. Everything is running and able to synchronize across our workspaces without any problem. So what we can do here is we can jump into a solar system to see what is happening inside. I'm going to do that right now. So in a solar system, we have a couple of new symbols. These symbols here, the ones that look like asteroids with little green bits sticking out, they are called energy nodes. You can think of an energy node like a phone charger. Spaceships will show up and essentially try to consume energy nodes. And by doing so, they will charge up. And so spaceships, when they're charging, is really good because spaceships need energy to survive. We can see a spaceship over here running around and trying to consume energy. However, spaceships are interesting because spaceships have behaviors. They aren't just dumb spaceships. They actually look at the universe around them and they decide what to do. And this particular spaceship is trying to get energy nodes that are safe. It's only basically going after energy nodes that are not being actively sort of hunted by other spaceships. And as another spaceship approaches this spaceship, it will likely run away. As you can see, it just happened right there. So we have energy nodes, we have spaceships, and they all are basically living their best lives in this virtual universe. The cool thing about this is that all of these solar systems are being simulated at the same time. So I can go anywhere in this universe and see something interesting happening. For example, there's a battle happening right here. These two ships are actually fighting over an energy node. They both want access to it because of the energy that it represents. And if we look at the battle, we see that I would go ahead and guess that this ship is going to win. But you never know. This is an open spaceship, open universe, and at any point another ship could just show up and disrupt this battle and change the outcome. I love simulations like this because they're full of emergent complexity. I have no way of predicting what is happening in this universe. I can only look and observe and see what these ships are deciding to do. So that's a quick overview of the Wasm space program. Let's talk about the architecture next. This is the architecture diagram. I want to draw your eye to 3 different areas of the diagram. On the right side, over here, we have our storage. The middle, we have our compute, and on the left side, we have our client. Let's start with storage. As I said at the beginning, the goal of this demo was to run the entire demo inside of SingleStore. So use SingleStore for as much of the compute and storage as possible. So on the right side, we have a database, which is in the SingleStore cloud, and the database is continuously backed up to object storage. This allows the database to be connected to from multiple workspaces, and all the workspaces can see the exact same data as it changes. In the middle, we have our workspaces. This is the compute of our simulation. Most of the compute happens in the writer workspace. The writer workspace is responsible for running each turn. Each turn is a single store procedure in SingleStore, and the store procedure runs in one massive transaction over 2.5 million update queries. Those update queries are really interesting. In addition to changing the data 2.5 million times a second, we're also running Wasm, basically Rust code compiled to Wasm and added to SingleStore. So I wrote the spaceship AIs in Rust, I compiled it to Wasm, and I added it to SingleStore as a new function type. So those 2.5 million update operations are actually running those functions that I defined as part of that transaction. And that's what makes this entire simulation feel alive. In total, during each turn, we run Wasm functions over 6 million times. That all has to happen consistently. So to make sure that no other workloads can affect the turns running every single second on the dot, we split up the workload between the writer workspace, which is this first one here in the middle, and the reader workspaces, which are the additional workspaces below. These reader workspaces have access to the exact same data as the writer workspace and can see it as soon as the writer workspace changes the data. So as those transactions are running, that data is immediately available. But we are guaranteed that no matter how heavy the read workload is, we can't negatively impact the writer workload. And that's really important when you want something to happen consistently at a certain time scale. So we have our reader workspaces, which is where we run our read workload. And we have our game clients. How do they connect to each other? The game clients use our data API, which uses HTTP to connect directly from the web browser to each of the read workspaces and run queries. The game clients are written in JavaScript and are a relatively lightweight client. They send queries to the server and they get some response and then they render it in the pretty way that you've been seeing. And that's pretty much it. That's how you build a universe simulation in one database. I've been working at SingleStore for over 9 years, and I've seen a lot of innovative technology at SingleStore over the years, and I love our database. But I gotta say, SingleStore 7.9 feels revolutionary. It's the first time I've been able to extend SingleStore with custom logic written in my favorite languages. And being able to do that and combining that with the power of SingleStore with huge amounts of transactions and analytics, massive concurrency, is just amazing. It changes how I think about building applications. I can honestly say that I've had so much fun working on this demo and building this universe and making it feel alive. I hope you had as much fun as I had building it, watching the demo. And I hope you go and take a look at it. It's available on GitHub. The source code's all there, so you can see how I built it and all of my mistakes, all the things I did wrong, everything I did right. You could sort of follow my story. And you can also run it yourself. So definitely take a look at that. In addition, there will be some follow-up videos that go into detail on the different features that I mentioned. Thank you so much for your time. I hope you enjoyed this. Have a great day.
Hi, my name is Bailey Hayes. I'm a software engineer on the Launchpad team, and today I want to talk about a new feature that we've added, Code Engine, powered by Wasm. WebAssembly, also known as Wasm, started in the web, but it's really a portable compilation target that lets you take languages like C, C++, and Rust, compile to Wasm, and then run in any Wasm-enabled runtime, like in the browser, on servers, and in SingleStoreDB. Once you have a Wasm module, you run a single create function statement that lets you load the Wasm module to SingleStore. But even cooler, Wasm modules have their own sandbox so that they create their own instance memories for each query that's run. And this lets us run it in the DBMS process. This gives us great speed and performance. You might be wondering, well, I already have the ability to extend the database with user-defined functions and write my own SQL. Well, a lot of companies and a lot of our users move data out of the database to do things like AI, ML scoring. Perhaps they have existing code and existing business logic that they want to run. And maybe porting to SQL is very complex and difficult, but you already have a high-level language that can compile to Wasm, and now you can push that code into the database. So by pushing in application logic and bringing your existing code to the database, I expect us to be able to see all kinds of new and simplified applications running on SingleStoreDB. So let's see this in action. You may have already seen our Wasm space simulation run by Carl. There are a number of ships, and each one of these ships is essentially its own user-defined function, its own strategy. The ships here are all running on the default strategy. There might be a few of them that are on the random strategy, but for the most part, they're green because they're extracting energy. They are prioritizing upgrading some of their systems and moving about the screen. Well, let's spice this up a little and add some new strategies. So right now I'll show the functions that we have. We have the default strategy and the random strategy. Random is really just move about the screen randomly. I have already created a Wasm module, and I've put it in a Google Cloud Storage bucket. And with create function, I create a new strategy called flee. And while we're doing that, I'm going to go ahead and create another strategy for battle. Now, if I list my functions again, we should see both of these new functions, both flee and battle. If you want to see what that code looks like, I wrote a really simple Rust program, and it looks for if there are any enemies nearby, and if there is an enemy nearby and we're running the battle strategy, then it will move towards or chase those other ships. Now that we've created that function, we can use it like any other user-defined function. So in this case, I'm going to insert several battleships into our solar system, and then I'm going to add several more fleeing ships that are going to run away from those battleships. And if I look for them, let's search for a fleeing ship. Actually, let's search for a battleship. They're a little bit more fun to watch. And I got the entity ID. Now we're going to warp to it. There we go. And as expected, the battleship is actively engaged in battle. So what this showed is that I was able to modify our simulation in real time without breaking it, without pausing anything, and run at incredible speed and implement new complex strategies. So it's pretty easy to imagine other different types of simulations that we could be running. This could be a logistics simulator of trucks moving across the highway. Or we could be simulating customers moving about in a store and trying to prioritize aisles, like maybe some of our energy nodes, and have a custom model per customer. This is very, very powerful. I can't wait to see what our users create. Thank you.
Hi, I'm Micah Bhakti. I'm the Director of Product behind the SingleStoreDB Cloud. And today I wanted to share with you a little bit more of a deep dive on our newest feature, Workspaces. So you saw Carl's demo of the spaceships and energy nodes and this massive kind of multi-tenant machine learning application built on top of SingleStoreDB. I want to show you how we used Workspaces in order to build that demo and how customers can use Workspaces to build their own data applications. So what is Workspaces? Workspaces allows customers to run multiple workloads across shared data. And the challenge that customers had before we introduced Workspaces is that data was locked within the confines of a cluster. So if customers wanted to run multiple applications on shared data, they had to make a choice. Either they could deploy multiple applications in a single cluster, where they had to find ways to manage performance impacts and make sure that analytic queries didn't impact customer-facing workloads. Or the second option was that they could deploy applications in completely separate clusters, but then they had to manage complex and expensive data movement between systems. Now that we have Workspaces, customers can launch independent compute workspaces for each workload, and then they can attach and detach databases as needed. This is super powerful. So let's take a look at how Workspaces work. Workspaces provide an isolated compute instance. And that compute instance can be scaled up or scaled down on demand. Users can attach and detach databases as needed, and each database can have one read-write and multiple read-only attachments. So this enables a bunch of customer scenarios. For instance, if a customer wants to run a customer-facing SaaS application, they can deploy that on a workspace. They can deploy a second workspace for internal telemetry. Maybe that's an application showing them performance of the application for their customers. And they can also operationalize machine learning models on that customer application data. Maybe they want to do targeted advertisement, or they want to do sentiment analysis on their user data. So that's kind of how customers would use Workspaces. Let's take a look and see what Workspaces look like directly in the product. I've logged into the customer portal on SingleStore.com, and here I'm in an organization that we've set up for the demo. And you can see I've got two workspaces deployed here. I've got an S32 size workspace that's powering the game engine, and I have a reader that's size S4. And you can see these are both connected to one database. This is the game database. And if I click on the database, you can see that I've got a read-write attachment to the game engine, and I've got a read-only attachment to the reader. So this is a super easy implementation of Workspaces, two workspaces, one database being shared between them. And it's really easy to create new workspaces. I can click on Create Workspace. I can do a new test workspace. I can select the size for that workspace. And this will determine how many vCPUs and how much memory is available for that workspace. And I can click Launch. And that'll go ahead and create a brand new workspace and start spinning that up so that it's available to connect to the databases that are available. Let's take a look at a slightly more complex deployment in another organization that I have. So in this organization, I've got a customer-facing application, I've got an internal app for telemetry for my employees, and I've got a machine learning model that I want to operationalize on top of that customer data. And currently, you can see each of these three workspaces is attached to a database. So this is similar to how you would deploy this in the old model, where each workspace can have an individual database. You can see here, this is the database for application production. I've got an analytics results database, and I've got a model scoring results database. The challenge I have is this customer application it's got all my data from my my usage of end customers connecting to my web portal, my SaaS application. But my telemetry needs to run using this application prod data and then store those results into these analytics results database. So what I want to do is I want to attach this application prod database to this app telemetry workspace. So I'll attach, detach. I'm going to select the application prod database. I'm going to save that attachment. And what will happen is that database will be automatically connected to my app telemetry workspace. You can see now that the app telemetry workspace has a read-only attachment to this prod database and a read-write to the analytics results. So I can query this application prod data in real time, operate on that fresh data, and store the results into this analytics results database. And the workload that's running against this app telemetry workspace will have no impact on the customer-facing application that's running on this other workspace. So let's say I want to run this machine learning model on this same application prod data. I can do the same thing. I can attach that database. I want to use application prod. I'll save that attachment. It'll attach that database to the workspace. And now what I can do is I can take this, this app telemetry data. I can store it to the prod database. I can read that with my machine learning workspace, and then I can save the results out to this model scoring results database. But let's say I want to take this one step further. Maybe my customer application, I want to actually use the model scoring results to change the application experience. So I'll go ahead and attach that database, the model scoring results as read-only. I'll save that attachment. And now my application will have read-only access to these model scoring results. So I can actually use this in my application in order to deliver maybe targeted advertisements, or maybe I want to customize customer experience based on the types of behavior that they have. So this is kind of a basic example of how customers can run multiple applications on isolated compute workspaces. They can share databases between those workspaces, and they can use it to leverage data applications across their organization on top of shared data sets in order to maximize the value of that data. If you haven't tried Workspaces yet, I would encourage everybody to go to the cloud portal, sign up for an account, and start playing around with it. Check it out. It's an awesome new feature, gives our customers a ton of power, and it's great to have hands-on experience with the product. Thanks.
Hey everybody! By now you've spent some time inside the Wasm Space program and learned about the amazing tech that powers it. So now you've seen that the game can support over 1 million ships, each one running its own AI through the code engine powered by Wasm, all of that done on a single SingleStoreDB instance. You've also seen how with Workspaces you can scale out to limitless reads against the database and against the game data as the game progresses. And what you might not realize is that the entire application is just running within a browser. There is no application server farms, no web servers involved at all. So how is that possible? I'm Julie Price, I'm a Senior Product Manager at SingleStore, and I'd like to introduce you to the SingleStoreDB data API that enables this massive game to run within a browser. Well, before we see it at work, let's take a look at what the data API is. It is an HTTP endpoint that enables you to run SQL operations on SingleStoreDB, and it returns the results in JSON, which is super common data format, really understood by virtually any client, very easy to build web-based applications, JavaScript applications that recognize and understand JSON. Now, the data API, it provides dynamic stateless connections, which means if you are playing or running the Wasm Space program and you're on your mobile device and switching cell towers because you're on the train commuting to work, you're going to have a great experience because each request and response is its own independent stream. Now, this provides the ability also to really easily integrate with things like serverless application tiers, SaaS applications, to build web and mobile applications because you don't have to worry about installing a lot of different libraries. You just write the commands and you're ready to go. Now, it also takes advantage of the common HTTP ecosystem and all of the optimizations, all of the evolution that is brought in by all of the companies that are constantly contributing to the HTTP ecosystem. Now, how is the data API different than other connection options for SingleStoreDB? Now, with TCP/IP connections like the MySQL client or ODBC and JDBC, you get a persistent connection. You don't get that network fault tolerance like I was just talking about with the dynamic stateless connections. Also, when you have your application and database running in different networks, you often have to set up a VPN, you have to set up load balancing, and all of this is very static and stateful. If anything changes about the VPN, about the load balancers, then the application has to change. With the data API, the image might look very similar, but we are taking advantage of out-of-the-box HTTP capabilities like HTTP proxy and load balancers, and all of this is very, very fault tolerant, it's very dynamic, and it gives us the ability to have those stateless connections. One other thing I want to mention here is the concept of connection pools. When you're opening a lot of connections against the database, it can really slow things down. So the data API not only manages connection pools for you, but it does it dynamically so that you don't have to worry about startup time or anything like that. And you don't have to worry about the headache of managing those connection pools. Now, one last thing before we see it in action, the life of an HTTP SQL query using the data API. Your application is just going to send the query request into the HTTP endpoint. The endpoint, the API, is essentially going to send that query over to SingleStore. It's going to get the results back, serialize them as JSON, and send them back to the calling application. Each request, each response, its own independent stream. Now let's take a look at it in the Wasm Space program in action. So, in the Wasm Space program, we've got all of these different solar systems. Each solar system has a bunch of ships that are essentially going around, they're battling with each other, they're eating up energy nodes, and we can see lots of activity happening here within the application. Now, what I really want to show you is the power of the data API. Now, all of the requests and responses back and forth from SingleStoreDB are happening with the data API. And just to show you in action, here's a query that's showing us the various different strategies that ships are using for play. So here we can run this query, we can see some are fleeing, actually most ships are fleeing, some are battling, and some are just using the default strategy. And as I run that query, you can see that the values are changing over time. Now, if I just wanted to see the total number of ships in the entire universe, in the entire galaxy, I'll just change that query and go ahead and run it. And we can see we're sending a request back every single time that I click this button. And all of that is happening over the data API, all through this web browser. So I wanted to thank you for the time that you've spent with me today. It's been really wonderful, and I hope that you'll check out all of the amazing new features that we're launching as part of this summer launch. Thank you.
Thank you, Shireesh, Carl, Bailey, Micah, and Julie for a look at the incredible new features in SingleStoreDB. As you can see, our engineering and product teams are constantly innovating to push the boundaries of what SingleStore can accomplish for you and your business. Next up, we have VP of Product Management, Yatharth Gupta, with our product vision and roadmap.
Thank you, Michelle. Wow, those were some amazing demos from our team. I'm looking forward to seeing how our customers use these features that have been launched today. Hi, my name is Yatharth. I'm the head of products here at SingleStore, and I wanted to talk to you a little bit about our vision at SingleStore. Since our inception, SingleStore has always been about enabling data apps. Our database is built with this intent in mind. How can our customers build data-intensive apps, real-time apps, intelligent apps, apps that do much more than just writing data? Back in the day, apps used to be about doing order entry, just adding data to the database. Today, apps are very different. Take a look at Uber. You are matching drivers with riders. You're providing real-time dynamic pricing. You're also getting other content, like offers that are tuned based on where you are and where you're going. At SingleStore, it is our belief that a single database, needs to support these intelligent applications. Not a cocktail of databases, not data constantly moving from one system to another, and hence adding more points of failure, but a single database. We have been evolving to lead the market to enable our app developers to be able to do this. We started at SingleStore with an in-memory database, allowing our customers to build apps with the fastest response times. As apps become more intelligent, they not only needed to read and write data at a high speed, they also needed to reason on data. We built, way back before it was popular, a single format that could be used for OLAP and OLTP, allowing customers to read, write, and reason on data. Zero data movement in a single database. We then added tiered storage. Customers were able to get the same speed, but also store data in a non-linear scale in an affordable manner when data was not being used. As customers' need for security and compliance grew, we continued to be at the leading edge of this. You heard earlier today about Wasm and Workspaces. You can, without moving any data, now build complex reasoning on data using arbitrary code. One small example is running sentiment analysis. Imagine you have petabytes of data in your database. You can now run sentiment analysis right there in database using Wasm. This has been a fun journey for all of us, but we have a lot of work to do. Our ambitions are of tall order, and our vision, build an easy-to-use single database for all your needs. This is what we are looking at over the next 3 years. We want to continue to enhance our distributed SQL. You can come to SingleStore, build geo-distributed, intelligent apps that read, write, and reason on data. Scale them up and down with your needs, and the data is always durable, highly available across geographies where you're using them from. Developers are our bread and butter, and we want to meet them where they are. We want to make it delightful for them to use our database. We're going to be investing a lot more in common constructs like Mongo, Postgres, or T-SQL APIs, in addition to the MySQL that we already have, allowing them to come easily to SingleStore. We want to deliver a zero-trust database. We are continuously enhancing all of our common controls, and we continue to add compliance and certifications that allow our customers to secure their data with the highest of standards. With petabyte-scale analytics, we will continue to enhance all of our offerings on the analytics side, whether it's JSON analytics, materialized views, to operating over very large sizes of data with the same speed and efficiency that we offer today. These are the 4 cornerstones of our vision, and we plan delivering on this starting today. Today we have Workspaces and Wasm that are launching, and we look forward to delivering on this vision, allowing our customers to build their most data-intensive apps with SingleStore.